And this assignment is called the 2-inch universe. And what you're going to be doing for this assignment is calculating different ratios or scales of universes. So it's kind of like when we started doing the 3D time scale, you were to put it into scale. So you didn't have, for example, Austin Canucks had a big large toad in the middle of it. It really wasn't to scale. But today's a little bit more about, can you determine a scale based on certain parameters. So we're going to walk through just the first example together, the first problem together, so you have a better idea of what it is that you'll be doing for this. For the activity itself, you'll need a set of these cards, and then inside the set of cards there's an information page. So it says right here, information key. And this information key gives you different sizes of things, like the diameter of the Earth, the distance from the Earth to the Moon, the diameter of the Moon. Okay, so you'll need those numbers in order to do this assignment. But the first question you'll be doing is, if the Earth is 2 inches wide, how big would the Moon be at this scale? So the one thing that I'm going to recommend you do is record the information on a piece of paper. You'd only need to record the final answer on your Google Doc, but I would recommend you write everything out in order to help you better understand how to do the individual questions themselves. So what we're going to do is we're going to go to the information key and get the rest of that information. So the Earth normal size is 8,000 miles in diameter. And then the other information we need, we're going to, whoops, not the Earth. Sorry. The Moon. We're trying to figure out how big the Moon is in inches if the Earth is 2 inches, right? But in order to do that, we do need to know the diameter of the Moon itself, which is 2,000 miles. And one thing that I want to recommend is that you make sure that you set up your problems over and over again very, very similar, because you can rearrange these in different ways. But I'm going to give you one example, and if you find a way that you want to go through it and set it up differently, you certainly can. Okay, so the first thing you're going to do is you're going to set up a ratio. You can either set it up to where you have your Earth all in one line, or you could set it up to where you have Earth in one side of the formula. And we'll just be doing cross multiply and divide. So I always say set it up so you have your two sides. So we're going to say on the top will be the Earth information and the bottom is going to be the Moon. And we said how big was what's the scale we're trying to get to for the Earth? 2 inches. So I'm putting 2 inches on top. And then we said that the Earth's actual diameter was 8,000 miles. So notice how I'm keeping the Earth on the top on both sides of the equation. Okay, and I can show you guys here in a little bit how you can do that a little differently. And then we'll just use the common expression. We're trying to find x, right? We're trying to find how many inches the Moon would be at a 2-inch Earth scale. And then the diameter for the Moon, the actual diameter, is 2,000 miles. And so simple terms, you cross multiply and then divide. So the first thing I'm going to do is cross multiply 2,000 times 2. And when we do that, what do I get? 4,000. So I get 4,000 is equal to cross multiply. So I'm cross multiplying x times 8,000. What do I get? 8,000 x. Okay. And then how do I get rid of the x, or get 8,000 away from the x on the right hand side? Let's add another page here to give us some more room. So we said 4,000 was equal to 8,000x. And the question you're trying to solve right now is how you get x by itself. So how do I get x by itself, Bailey?
You have to divide.
Yeah, you got to divide out 8,000 from this side, 8,000 from this side, and then 8,000 over here cancels out. So now we're to 4,000 divided by 8,000 is equal to x. And in this case, that equals what, Cora? 0.5.
Yeah.
And I would recommend you always keep like 2 decimal places, so 0.50, just to stay consistent in your numbers. 0.50, what's our unit of measurement?
Inches.
Inches, good. Okay, and that's our final answer. That's what you would record on your Google Doc for that question line. Okay, and one thing to just be aware of, the next question that you're going to figure out, it says, using the information from question 1, what would the distance between the Earth and Moon be at this scale? So now you're moving on to distance between them. And the thing that students often get confused about is what numbers they should use for that. Well, you're still trying to figure out the distance between Earth and Moon, and it's still going to be a ratio. So Earth, Moon, set it up so you know you can put your numbers in. A diameter is a distance across, so you can still use the known diameter of your Earth. 2 inches diameter equals to 8,000 miles across, right? And then x for the moons equals how many miles between the Earth and the moon itself. So just as a little tip there, what you will be doing is you'll continue to use the information on the Earth. So 2 inches is a scale you're using, and your diameter of the Earth is 8,000 miles. And then to find the distance between, if you go to your information key, it says distance from the Earth to the moon is 240,000 miles. So your moon distance between now is going to be x equal to 240,000 miles. But the process at that point is the same. So you would take and multiply what first? 2 times, yep, so 2 times 240,000 is equal to 8,000 times x. Okay, 2 times 240,000 is what?
480.
Good, 480,000. And we still have 8,000x. How do I get rid of my 8,000 on this side of my equation? Divide it out on both sides. Once you've done that, that cancels. 480,000 divided by 8,000 is what? And that's what you would figure out. Okay? Is when you get to a point where the numbers are super large for the other questions. For example, the Milky Way says it's 6,000 trillion miles in diameter. And then it says 1,000 light years. You can use light years instead. You just have to make sure that if you do that, that you've used light years on both parts of your equation on that right-hand side. So if you have inches on this side, both of these are miles. You can't go miles and light years. Okay, so you would have to figure out, well, how many miles would that top number, or excuse me, how many light years would that top number be then? Because sometimes these numbers get really large, like the Andromeda Galaxy, 220,000 light years, which is the equivalent to 1.3 million trillion miles. So when you get into really large numbers like that, you might want to switch to a different unit into light years to better assist you. So that's the first half of the assignment. Again, that is due tonight. And then the second half is using that Sizing the Universe website to just go through some virtual, more, I would say, visual versions of different comparisons between planets and our Earth, size relationships. So you'll work through those questions and then submit them. You can work in groups of 2, but I will be assigning you guys group numbers here in class so that you can join those group numbers and work together on those. You can also opt to work individually. So if you weren't here today, or for those of the people that aren't here today, they can just work individually on it. And you guys would have that option then to work together. Questions you have?